Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Advanced Fortran programming. Now, in this tutorial, I'll explain you guys a little more in detail about that optional parameter. Okay, applying with a new example. I mean, it's exactly the same example but with a little modification, and I'll explain you guys in little in detail about certain stuff that comes along with that you have to keep in mind while working with modules or working with functions and all. Okay, now uh, what I have here is that it's exactly the same module that we used last time and the same program which we used last time, but I saved it in an okay I saved this in a new file called a save underscore ex, means save example. Okay, what I did is that I just made some changes to it in this line. Okay, in this if statement. Okay, if in the last program we just had only this line, so what I did did here is that along with this condition I merged another condition called as debug equals 1 equal double equals 1. So this is more this function now, I mean this function will take into consideration the debugging even little more much more clearly when in compared to what we did last time. Okay, and that the same debugging stuff is printed over here and will be done in a different manner. Okay, now I use this module name is part 2, and this time I have included no variables inside this module, and then using this contains I wrote this return a recursive factorial function. Okay, you ignore these commented portions of the code right now. We'll come to that later. Okay, I've included this debug keyword as an optional parameter inside, and then n as the normal value. And now when n is less than or equal to 1, okay, then all this statement gets executed. If debug is present at the same time a debug value is equal to 1, then this statement is run. So sometimes if somebody enters a new value for debug like 2 or 3, okay, this debugging will not happen, but only when a debug is 1 it will happen. At the same time, if debug is not all present, then not a problem, this part will not work. Okay, it'll just this if statement it will not work and it will just work here. Okay, similarly same thing happens here, but when the debug is present at the same time when the debug is equals 1, what will happen is that this debug also does and in debug also happens. Let's see, debug also happens, and then I forgot, f1 should be equal to f1 star n and then return and then return. Okay, this way we're ending it over here. Fine. Now okay, now let's see, if I were to now this is how the function, I forgot to mention this over here, but anyway that's not a problem. This part will be ignored. So anyway, if I were to compile, build and execute, if I were to compile and build this, it looks fine. And let's look at the program here. Initially I set the value debug to be 1, so this will work under debugging. So if I were to compile, build and execute this, okay, sorry, now if I were to enter 5, it debugs properly. It just prints the value of n for each and every value of n, and then it shows how it returned back and all. So it gives us a debug nicely. Okay, now what I do is that I just set this debug to be 0 here in the main function. Alright, now if I were to compile, build and execute this, okay, now if I were to set 5, there you have it. Okay, it works fine. Even without the debug value, it just works fine. Okay, the debug is not present, but the program is working fine. Now suppose this is 1 and I do not enter the debug value. Okay, now this will return false, so this part will not happen. Okay, so even with the debug value 1, so since I'm not passing into the first function call over here, all these values will not happen, and because of this kind of a arrangement, of code, okay, when this is present, when this debug is present, okay, this value will be true. When this is true, this function will be recursively called using this debug value, so this will not happen at all, so no problem at all. Okay, now if I were to run this, it just gives me a warning in the function stating that this debug is not used. Well, it's okay. If I were to build this, no, still a warning, no problem. But if I were to run this, there you have it. This time when the debug is, let me run this again, compile, build, and run this again. We give a value, okay. Even with the debug, when the debug value is not included into the factorial function, it still works. There you have it. Okay, now this is how your optional parameters can be very helpful. If you just pass parameters accordingly and nicely, you can make the same function do a lot of jobs. Okay, so if the parameter is present, it will do a certain job. If the parameter is absent, it will do a certain job. At the same time, the parameter has different values. You can make the functions and subroutines do a different jobs based on the application. Okay, now this is just a simple implementation. If you want, you can go for complex implementations also, but it's your call. Simple as that. Now let me tell you guys how to work with the save function. Okay, now what I do is that this time I include this integer counter here, and actually I apologize, because in the last tutorial when I was about to explain about the save command, I kind of messed up as to what the explanation is. So let me correct that and explain you guys properly here. See, whenever a function or a subroutine gets called, let's say, okay, and when that subroutine is when the job of that subroutine gets over, or a function gets over, all the values inside that subroutine, like this function over here, the value of n, the value of debug, etc., whatever it is, all the values it had initially inside the function, okay, or inside this function, once this function gets over, those values get deleted. So when you call again, when you call that function again, what happens is that these values get initialized from the beginning, and the values it had in the previous run will not be there. Okay, now suppose let's say I ran a function or a subroutine and I want certain values to be present. I want to use those values to run this again, to run the new value like that. Okay, what should I do with that? Then if I want to use those previous values in the function when I use it again, now how can I do with that? It's simple. Subroutine does it. Subroutine function helps you, the save statement helps you, save keyword or save statement helps you to do that. Now if you want to save a keyword or something of that sort, okay, there are two, save a function or save a variable. Okay, what you have to do is that you can type save attribute like this, okay, or you can separately use save like this. And if you have multiple variables to save, it's like just go like this, okay, and so on. Either you can save using the save keyword while defining it, or use it separately and define it here so that your variable gets saved. Now to give you guys a hint as to how this works, okay, let me compile this program, and let the debugging option be 0, okay, so that it won't be messy, and let this be let me enter this so that it doesn't show any error, it doesn't show any warning and all. So initially, since the debug is 0 here, it won't show all the debugging options. So if I were to compile, build, and run this, okay, press 5, it prints nicely all the values. Now the point you have to keep in mind is that this counter variable gets activated for every call of the subroutine. For every call of this function. So when it's initially called, the value of this function is the value of the counter in this function is 0. Okay, 0. Okay, so during the first call, after executing these lines, Okay, let me keep it after executing these lines over here, just follow my mouse cursor. Okay, after executing these statements, this statement follows the nil number 17, this statement follows, and counter gets incremented by 1, and this statement gets printed, so it's counter equals 1 gets printed on the screen. And as and when it does it, as we like guys look at the code over here, it initially calls for 1 factorial. So when 1 factorial is called, called, okay, this statement gets printed, this statement gets done, and it goes over here. This f1 is returned out and it goes out. Okay, when 2 is called, it gets print, the counter becomes 2. Instead of reinitializing it to 0, since we use the save option over here, the counter variable is not reinitialized, rather it retains its previous value. So when this counter gets incremented by 1, okay, it prints counter equals 2. Okay, so if you guys can clearly notice that this function, because of this counter argument, because of this save option, the value of counter is being retained even after the termination of the program. So even after the termination of the function call. Okay, this way, now what you see is that it runs twice. Because of the recursion, for 2 factorial it has to run twice, so you get 2 increments. For 3 factorial it has run thrice, so you have 3 increments. For 4 factorial it has to call itself 4 times, so 4 increments. And finally for 5 factorial, 1 call by the system, 1 call by the program, and 4 recursive calls, so you have 5 increments. And so ultimately, if we see to do this program, to print the factorial from 1 to 5, you have 5, so you have like 15 calls. So this function is actually called 15 times. Okay, now let me include the debug option also. If I were to save this, okay, compile, build, and execute, let me say enter the same value 5. Okay, you guys notice it just prints alternatively. It's just between this gives an indication that this debug indication that the counter value is getting printed, and then the end value becomes 5, the counter value gets printed, and the end value becomes 4, counter value becomes 13, like that. It just works out very nicely. Okay, very nicely. So this is an advantage of save value. But actually I'll correct this comment over here. It's actually a program to use why to use save keyword in detail. Okay, initially I had some errors. Initially I had some debug issues. I was correcting that, so that's why I used why not. But anyway, it's it's actually why to use save keyword. Okay, but however, there is a warning. There is a caution you have to keep in mind. Okay, now we saw this option over here using the save keyword. With this turned out to be fine. Okay, but suppose if I were to don't save it, we have to compile this, build this, and run this with the debug on. Okay, even then the counter value gets nicely printed. Now this is a little problematic. Now see, when the function call gets over, but since we remove the save counter option, the value is still preserved. Okay, even it should not be preserved, but it's still getting preserved. Isn't this a little troublesome kind of? Not trouble. Isn't this a little ironic that after the function call is over, it's still getting printed? Yeah, this is a kind of an issue that can come in a compiler, in the Fortran compiler. Based on the compiler you use, okay, based on the compiler you use and the normal compilation procedures, this will even without the save option, sometimes it will just work fine. But sometimes when you use some regular seriously optimized coding, seriously optimized compilation flags and all, this you may not get the counter value repeated. Okay, maybe in one of the okay, hold on guys, I'll just show you guys a question in Stack Exchange. I'll show you guys a Stack Exchange where this explanation was given very nicely. Hold on. Hey guys, we are back. Okay, when I was trying to look at how the save function works, I found this nice answer in the Stack Overflow. I just nothing much. I just typed save function in Fortran or save keyword in Fortran, and this question, I think this line, this Fortran 90 Fortran save statement Stack Overflow blah web page directed me over here, and I was just reading through this to get a clear idea of what's going on. And there is this user, I don't know what's his name. Let's see, MSB. I don't know. I think it's using his keyword. Okay, what he did is that he kind of gave a very nice explanation to what and how does the save statement works to save the values between subroutine calls and all. It worked out. He gives with a small fragment of a code and explains the same, and he says that there is an issue. This behavior might be different from Fortran 77 and modern compilers, and he says that there are some issues over here. Okay, and the most important thing I like to show here is that this example which I found on which given by MSB. Okay, this person MSB, thank you sir, your example was nice. Okay, have a look at this program over here, I mean subroutine over here. He just made a small module called as subs, which contains, and with the keyword contains, he wrote a subroutine inside called as a sub with two values, I and control. I is rather an integer, and control is a logical input. These both of them are inputs, and he used this j variable. He assigned this j variable to 0, and this j variable is kept as save. Okay, and introduced an integer k. Okay, now j variable is incremented by I units, and then he puts a condition that if control is true, if control, then k equals 0. So suppose if somebody enters control to be true, okay, then k is initialized to be 0, and then after initialization k gets incremented with I, and he is using this write statement to print ijk values over here. Okay, and then he ends this module, and then he writes this program over here, and then calls these modules with values 3 and 4, with 3 and 4 for I and true and false for the control. When the first subroutine gets called, j is 0, k is undefined, I is 3. So in this line, j from 0 it becomes j becomes 3, and that goes fine. Now since the control is true here because during the first call, now k is initialized to be 0. Now with that value, when he passed I, when the value of I is passed, k gets incremented to 4. Sorry, k gets incremented to 3. K gets incremented to 3. So when he prints ijk here, this ijk gets printed, and it's so when it gets printed, and that value gets printed as 333. So I is actually 3, j is initially 0, incremented to 3, k is initialized to 0, and I equals 3. So ijk value gets printed to be 333. Fair enough, it works fine. Now he calls the same subroutine second time. But this time with I value to be 4 and the control value to be false. Now if you guys notice here, it goes like that, j becomes 4, no problem, but here the control is false, so this if statement will not happen, so k will not be initialized to 0. But here if you add, now here in this line, k is incremented by I, but k does not have a value here because it's not initialized. So this should turn out to be this should turn out an error, but when this right statement works, okay, k gets I gets to be 4, that's fine. 7, j becomes 7, because in the previous previous function call I was 3, so j became 3. Okay, now in this function call j is 3. To start with, this does not work. Okay, j becomes 3, so when I is 4, when I is added with j becomes 7, so j becomes 7. So j is 3 plus I is 4, so j becomes 7 and is printed. And k is 3 in the at the end of the function call. K is 3. Okay, but k gets incremented by 4 units. Though it's an illegal function, it's not a proper or an illegal function call. It gets incremented by 4 units and gets printed as 7. Okay, now this is when compile using Fortran. Okay, now he gives an explanation that when you compile with he gives the same explanation over here, but in a short manner. But so this actually call is false. But when you compile this with the Fortran, the one we are using here, first call it prints out nicely. The second call it prints like this, 477. Okay, but when you compile this with iFortran or iFort or Intel Fortran compiler, okay, with serious optimizations, k is lost. Okay, the initial value of k gets lost. Already when the run the value of k which was initially there gets lost, and when this assignment is actually called, k is by default set to 0. Even without this word, it is set to 0. Even without this assignment is even without the k being assigned to 0 here, it gets the Intel compiler assigns k to be 0 here, and then adds 4 to it, the I value 4 to it, and then saves it. So when ultimately it prints out to be 4, so the previous value of k is actually lost here. So that's why you get the result 474. But when iFortran compiler is used with and debugging options, not the manual debugging options that we saw here, but the debugging options that were available with the compiler itself. Okay, at runtime, what happens is that the ijk value gets printed nicely during the first call, but when the second call happens, it shows a warning something like for RTL severe 193 runtime check failure. The variable subs mp and subs underscore mp underscore a sub and underscore $k something, meaning if you guys look at it, this is actually this subs mp is nothing but, let's see, okay, fine, that is not a big deal. It just it's indicating that if you guys can look it out nicely, a sub is actually this subroutine, and subs means a kind of a subroutine notation, I suppose, and mp means maybe module and program, I suppose. These are like internal compiler keywords kind of stuff. Okay, and this $k, I think it's referring to the variable k. Okay, it says that this variable is being used without being defined nicely. So this debugger nicely point out the Intel Fortran debugger here in this example. It pointed out nicely. Okay, now point out nicely. So this is the reason why you should use save function a little carefully. Now this is one of the reasons why you should use save function carefully, and probably this is the reason why even with the save function, let me build this. Let me run this. This is the reason why even when the save function is keyword is put, even when the keyword is removed, it just works exactly the same way. The optimization flags, when the optimization flags were used accordingly, then this kind of error won't happen. Okay, now there is a problem with there's actually an inherent problem with save variable that I have to tell you here. Please do not use save variable, do not use the save command unless otherwise required. What happens is that when you use the save command or the save keyword for subroutines and other functions, especially during parallel programming and or in parallel threading kind of applications and all, okay, these are little hi-fi stuff, but if you want to use in those places and all, what happens is that this save function, the save keyword, will cause a tremendous amount of trouble, where it will make the optimizations a little harder for the compiler to do, because it has to retain certain values after compilation and stuff. But when you're doing parallel programming and parallel processing, which is very much possible in Fortran and C and other compile languages, mostly in compile languages like C and Fortran Basic, in short, okay, the save keyword does cause a lot of issues. So the practice is use the save keyword very carefully and only when it is absolutely necessary, okay. And if it's not necessary, I strongly recommend don't use it. It just becomes a real pain and a real trouble when you're working with parallel programming and when you work with very complicated modules and functions and all. Okay, that's all I have for you guys in this tutorial. And for this person MSB, thank you so much for your thank you so much for your explanation. It kind of helped really much. Okay, I recommend you guys to type this for save function or save keyword whatever in Fortran and have you guys and have a look at this. There are other explanations also internet, but I found this very nice. So this is I thought of thanking this person. Thank you, sir. Your explanation was really nice, and thank you guys for watching. That's all I have for you guys in this tutorial, and I'll see you guys in the next tutorial. Bye.